Hello everyone, this is Mr. Fu. I'm here to share with everyone how to prepare for the GCE O-Level Singapore version chemistry practical exam. At home, we do not have access to the lab, chemicals and apparatus. So how can we practice our practical skills other than enrolling ourselves at expensive practical sessions at tuition center? We can do some practice at home to hone our practical skills. Basically, more on the analytical part of it. So today, I will share with everyone how can we prepare ourselves for the chemistry practical qualitative analysis known as QA. Now, information, there will be no tests involving lead ions and sulfur dioxide gas due to safety concern. So the other cations, anions, and gases can be tested in the practical assessment if QA is one of the questions tested. What is QA? I shall not indulge in sharing what is QA, since most of the listener will have an idea what is it. But we need to know the focus of this assessment, that is to test for cations and anions. There will be heating involved, and most importantly, the skill in observing the appearance in terms of color and sometimes the texture of the substance. So to make a solution, there is two ways of doing it. Number one, based on the solid given, you will be required to dissolve the solid with either water or acid to make into a solution before the solution was used to do further testing to test for cations and anions respectively using precipitation reactions or other reactions like acid carbonate reactions. Or the solid could undergo thermal decomposition or heating to form oxides before adding water or acid to make into a solution. So these are two ways in making a solution before we can test the cations or anions present in the solution. Now, before we start doing the practical, it is important to recognize some relationship between the colors of the solid with the identity. Based on the colors, we are able to deduce possible substances in the unknown given in the question. So if the solid is white and solution is colorless, by the way, we cannot say a solution is white, because if the solution appears white, then it is not a solution. It is a suspension which have white solid suspended in the mixture. We cannot say a solid is colorless. We only describe solid as white. Colorless is used to describe liquid or solution. So these are the possible substances which comes mainly from group 1 and group 2 metal ions, as well as ammonium and zinc ions. If you observe a black powder, it could either be carbon, copper 2 oxide, or iron 2 oxide. A gray solid will be mostly metals, but not copper. Copper metal is not gray. Copper is reddish brown or pink. If you observe a solution as blue, very likely it will contain copper 2+, but may not be all the case. Sometimes it could be other transition metal ion that is not in the syllabus, but you're not required to identify metal ions or anions. They are not part of the list in the QA table. Green substance suggests possible presence of copper 2 carbonate, or it could be a compound that has iron 2+ ions. Yellow will be iron 3+ aqueous. Sometimes you are required to heat the solid or liquid and use chemical tests to test for the gases involved. So you may be required to evaporate the water of crystallization first to convert the hydrated salt to anhydrous salt. This is the water of crystallization. And if you are required to thermally decompose substance, as the question requires you to do heating, then to observe possible inference. For example, if the gas produced bubble into lime water produce white PPT, then carbonate ion is present as carbon dioxide was produced. If oxygen gas was produced in the thermal decomposition process, then the substance may be either a metal oxide or even metal nitrate. Ammonia gas produced from the reaction could suggest the presence of ammonia ion. Okay. If the solid changes from green to black, likely to be copper 2 carbonate decomposed to form copper 2 oxide. And if you observe the solid changes to yellow when hot and back to white when cold, it could be zinc ions. So if a gas is evolved when a test is carried out, the student should identify the gas and deduce the identity of the ion present in the unknown substance responsible for the gas given off. You should be very, very familiar with the solubility table to identify what are the soluble salts or insoluble salts, what are the soluble hydroxides and insoluble hydroxides as well. And you have to be very, very familiar with the reactions of acid with various substances, because if there is a gas evolved and you are able to identify the gas, for example, CO2 evolved, and if you add acid to a solid, you're required to identify the solid, right? The solid likely to contain carbonate ions. Now, these are the important general points to note when doing QA. Note the appearance of the unknown in its solid or in solution. The appearance may give a clue to the detection of the unknown. There are several possibilities, so do not jump into conclusion, but carry out further tests. For example, there could be two different cations in a colored solution, copper ions and lead-2 ions. Because copper ion is blue and lead-2 ions is colorless, you couldn't see there is lead-2 ions. So you need further testing to justify for the presence of lead-2. These two ions could be mixed together in the same solution. And the blue copper 2 plus may overshadow the colorless lead-2 plus. So if a colorless solution is given, then it could also be, it cannot be an insoluble compound. So immediately, right, if you see a colorless solution, right, let me tell you, it cannot be, number one, it can't be lead-2 ion. So lead-2 chloride or sulfate cannot be present. So, so in the solution where you are testing for the unknown cations and anions, if you have one anion as chloride or sulfate, the cation cannot be lead-2 plus because it was a solution, not an insoluble compound. So it's something for you to take note. Okay, very important. And another deduction is that this compound, because it's colorless, it won't contain a transition metal ion. All right, but it could have zinc ions. But zinc is not really a transition metal. It's pseudo. It behaves like transition metal, but it also have properties that are not related to transition metal. It's like in between. Okay, read the instruction carefully. You are not required to identify R means that the components in R are not the standard ions in the syllabus. Don't waste time trying to fit an observation to the QA table. You are just wasting your time. And you have to know the purpose of each test and have some basic knowledge. You cannot do your QA test blindly. You have to know that, why this reagent was added at this point, why that reagent was added. For example, if you see acidified barium nitrate solution, you must suspect sulfate ions, which could be either a positive or negative test. If the reagent given was acidified potassium manganate, then you are suspecting presence of reducing agent in your sample. So you cannot just do the practical and get the color change without understanding what you're trying to test for. Okay, so because the list of ions are given, okay, because the reagent is given, you're supposed to predict and then test your hypothesis. So you're supposed to do mini hypotheses along the way, like trying to guess and check your answer. That is the attitude towards a QA assessment in chemistry practical. It's not about doing a research where you do not have an idea what's going on. Okay, it's not something you start from scratch. You have a list of ions to identify. You're just trying to guess, predict, and then test to verify if you are right or wrong. Okay. Do not waste time thinking about what is the identity at that point. If you couldn't get any sensible result, just move on because time is limited. You do not have the luxury of the whole day to do the whole practical. So please move on in view of the time limit. Okay, just move on. Okay, it's better to lose 1 or 2 marks than to lose the 10 marks thereafter. Quantity of a substance. So these are some good practical techniques to take note when you carry out a practical, like just place 1 spatula of solid into the test tube. The amount should just cover the curved part of the bottom of the test tube. Okay, meaning it should not be too much. Because if you have too much, then you may require more reagent to react with this solid. And you may not get the expected result because your test tube has a limited capacity. So if you have too much of it, what happens is that there's not enough reagent to react with the solid to give you the desired results. Now, if plastic dropper is provided, some schools do provide, then you are reminded to add about only 1 cm depth or 1 to 2 centimeter cube for each test. Try not to over add your solution. Don't add too much. Okay, the same reason apply. Too much reagent use will lead to inaccurate observation. Total amount of reagent should not exceed a test tube full. So if you are required to add a series of reagent, it should not be added to a test tube full. All right. In any test where the solid is added to a liquid, the candidates will be well advised to add a little of the solid at first and then more if necessary. Okay, so these are the precautions. I shall not spend too much time on this. You can just read yourself. Just be careful when you do heating. Be gentle and do not point at anyone to prevent accident from happening. I do not want a situation where you are wasting time to clear your mess and lost precious time to do an assessment. Okay, you need to have sufficient practice before this actual assessment to avoid all these accidents from happening. Okay, now the color of the solution suggests the cation. This is the clue. Color of solution or solid suggests the identity of the cation. The positive ion, it could be ammonium or it could be other metal ions like copper, iron 2, zinc, lead, etc. But the gas evolved, the identity of the gas evolves is related to the identity of the cation. Okay, just bear that in mind. Okay, next. These are just some practical precautions when you carry out your practical. So remember to hold the dropper just above the mouth and do not let the dropper to touch the test tube to cause it to be contaminated. Okay, do not allow the dropper to touch anything else except the reagent itself, which you need to transfer from the reagent bottle into the test tube for testing. Do not put the dropper on the bench because the bench is not clean. There could be some residue of chemicals that can contaminate the dropper and affect your results or make your results inaccurate, giving false positive results. When adding reagent to unknown substance, please add slowly and ensure mixing. If you do not mix the reagent well, only the top portion of the sample can react. So if you can shake thoroughly, that will be good. But if you are given a glass rod, then use a glass rod to stir to ensure better mixing. Okay, you need to ensure that the solution or the reagent is well mixed. If you're asked to add acidified reagent to the sample, it means you have to collect the reagent in the test tube and add an equal volume of dilute sulfuric acid or other acid instructed. Then add the acidified mixture into the sample. Do not add reagent and add acid separate. You are supposed to acidify the reagent. For example, they give you potassium manganate solution. You should add acid to it first, acidify it, then use the resultant solution to test for your reducing agent. Okay, and not add them to the unknown separately or one after another. So to test for gas, these are the things to look out for. Is there any effervescence? What is the color and odor of the gas? If there's no odor, that means it's odorless. Action of the gas on moist litmus paper must be mentioned. You also should perform a confirmative test on the gas. For example, you use lime water to test for presence of CO2. You use lighted spleen for hydrogen, glowing spleen for oxygen, etc. Okay, please be very familiar. Although the cheat list is given, it is good that you remember so that you can carry out the task faster, write your answer faster, and you just check the cheat list and confirm your answer. You must use a litmus paper, but if let's say, okay, there is not enough time, okay, you just do the confirmatory test. And then once you identify the gas, you work backward to determine what could the result be if you use litmus paper. If you want to proceed faster, you can skip the litmus paper, but in the observation, right, you must write down the result with litmus paper, even though you may not have carried out. Okay. So this is how you test for carbon dioxide. I'm sure your teacher have reminded you how to do it. How should you connect the test tube of reagents to the lime water? Remember, the lime water do not add too much. Half filled doesn't mean half the way. I will recommend you about 1 to 2 cm height. That's it. Okay. If you add too much lime water, it will take more CO2 to form the PPT with lime water. Okay, that will be a waste of time. You need to increase the speed of you doing. You need to complete the paper within the limit of time. So the short end of the delivery tube is connected to the rubber band, and you are supposed to stopper the test tube with the longer end of the delivery tube connected and submerged into the lime water. Okay, so if you are required to heat the reagent to increase the speed of reaction, please be reminded, for safety reason, remove the tube containing lime water first to prevent backflow of the solution and cause possible cracking of breaking of apparatus. Okay, to prevent the solution from being sucked back, and the suck back will create a pressure that will break the glassware. Now, these are the confirmative tests, the effect of litmus, color, and odor that you should remember for all the gases that could appear. And you also must know the formula for lime water, calcium hydroxide, and the product form when carbon dioxide is bubbled into lime water. Please do not just say pass the gas, say bubble the gas. And the effervescence is not observed in lime water, as many of you have written. The effervescence is observed in the reagent when the acid reacts with the carbonate. Okay, there is no effervescence when the carbonate decomposes upon thermal decomposition. There is effervescence observed when acid reacts with the carbonate. Okay, so the effervescence is observed when the acid dissolves in the carbonate, the colorless, odorless gas form, and this gas turns moist blue litmus paper red, and the gas is bubbled into lime water to produce the white PPT. And these are the observations for other gases that could be tested. Sulfur dioxide not tested for practical. I shall skip this, but do bear in mind this may be tested in the theory section. Chlorine, ammonia are popular gases that could be tested. And please remember to note the color. For chlorine, you can write greenish yellow, but if let's say in the actual practical it appear more green, you can also write reddish green. But in theory, in the syllabus, right, it was written as greenish yellow gas. Okay, that is actually the theoretical color, but sometimes the color may differ a bit due to the lighting. So we do not fixate to one color because we understand the circumstances we are in, the environment have an effect on the color observation. So there is a range of color that the examiner might accept. Okay, for example, iodine solution was known to be brown in the book, in a textbook, but if you read as yellowish brown, because it did appear a bit yellowish brown for that specific concentration in some of the iodine, then it's accepted actually, yellowish brown, but yellow is not accepted. Yeah, something along that line. So there's a range of color that is accepted by examiner, but there's also a range of color not accepted. Okay, so if you are not very sure and you are certain that the element or the compound is something that you are familiar with and you remember the color, just write the theoretical color. That will be accepted as well. it will be a safer choice. Then you need to know how to write the observations for the cation ions and anions. And of course, questions on ionic equations will be tested. And these are the thinking questions which test you on your understanding of the procedure. Like, for example, what is the role of acid is to remove any carbonate present before you do the precipitation reaction between the anions in the unknown and the reagent. The cation of the reagent, for example, barium 2+, is added to test for sulfate ions. And why barium nitrate was used instead of silver nitrate? Because addition of barium nitrate result in the formation of white precipitate with sulfate ions are present. So if you use silver nitrate, silver sulfate is sparingly soluble and it's almost soluble. You'll not be able to see the precipitate and hence deduce the presence of sulfate. Now, another reason why acid is why, like for example, why barium nitrate solution or silver nitrate solution, these are the popular reagents tested, right, for chlorides and sulfates, iodide, etc., are acidified. So these are the questions. So the reason for this, right, is that to prevent the precipitation of carbonates. Okay, to prevent carbonates from being formed. Okay, so any precipitate formed, okay, will verify the presence of sulfate ions or chloride ions. So whatever precipitate that was formed, right, it will not be carbonate because it was already removed. Okay, carbonate ions already removed. If there's carbonate present, what happens is that the acid will react with it and you will see effervescence or colorless, odorless gas. Gas turn moist blue litmus paper red because carbon dioxide is acidic. Gas bubble into lime water, produce white PBT in lime water. And the precipitate that was observed when you add barium nitrate or silver nitrate will be confirmation of sulfate or chloride ions. Can lead 2 ions be used instead of barium nitrate? Yes, because they form precipitate with sulfate. So the question may not, the practical may not be given for lead 2 nitrate, confirmed, but they may have a question, additional question below to test your understanding. So they may ask, instead of barium nitrate, can I use lead 2 nitrate? Will I get the same result, etc., and why? Then you write equations to justify. Same thing for silver nitrate to use instead of barium nitrate for chloride iodide as well. Now, so why is nitric acid added and not hydrochloric or sulfuric acid to test for chloride or sulfate? Because you don't want to generate false positive result. Come on, you're testing for chloride or sulfate. How can you add hydrochloric acid and sulfuric acid? But how do you phrase it nicely to get the mark? You need to say, okay, formation of white precipitate is inconclusive. Okay, it's inconclusive that it's inconclusive that chloride or sulfate ions are present. Addition of hydrochloric acid and sulfuric acid will introduce chloride and sulfate ions into the unknown. Definitely, when silver nitrate solution is added, a white precipitate of silver chloride will be formed. So similarly, when barium nitrate solution is formed, a white precipitate of barium sulfate will also be formed. So you are testing for chloride and sulfate, so it is not allowed. I'll say no. No way. You should not add. By right, you should not add an anion you should not add an ion that is required to be tested. Okay, so the answer, I mean, you could understand the reason, but sometimes it is hard to write down the answer in written communication. So this is how you phrase it. You don't want to introduce chloride and sulfate ions to generate false positive results. Okay, and the result hence will be inconclusive. Now, these are the reducing and oxidizing agents to take note of. So other than potassium iodide solution, there is also acidified iron 2 sulfate Then oxidizing agent will be, the popular one is acidified potassium manganate, and how do you test it? And the iron 3 chloride solution. Okay. Now, I shall not go into the detail of what else to take note. Like in general, it's like color change, formation of PPT, evolution of gases, and evolution of heat. So sometimes feeling warm, the test tube feel warm is actually an identity also lah. Okay. Now, these are some precautions to write observation. Number one, please know the purpose of the test and report accordingly. Example, if the test is for cation using aqueous ammonia, the purpose is to test for cation from the color of the precipitate. Do not report that ammonia gas evolved here. That's wrong. You have to look at the test and understand what is the purpose. Are you testing for cations, anions, or the gas? Okay. Do not use it in all your answers in your QA practical. Be specific, stick the subject. Don't just say it is blue. Say the precipitate is blue. That is even better than it is blue. Don't say it is pungent. Say the gas is pungent. Don't say it is colorless. Say solution is colorless. Do not write in point form. It's not allowed. Only write in concise, complete sentence. When the gas is evolved, report all this. Effervescence, if there's any. But some gases do not perform. For example, the test for ammonium ion, where ammonia gas is evolved, when ammonia ions reacts with alkaline and warm. For this particular reaction, there's no effervescence because ammonia gas is a soluble gas and it will dissolve in the solution and no effervescence will be observed. Another gas with no effervescence is chlorine, because chlorine is another soluble gas. The gas that produce effervescence will be carbon dioxide, hydrogen, oxygen, because these gases are insoluble in water, hence forming effervescence. And for test for nitrate where ammonia gas evolved, in this case, the reaction is quite vigorous, so there will be observation of effervescence. Although ammonia gas is not an insoluble gas. However, due to the amount of heat released in this reaction, effervescence will be observed. Now, because it is so warm that the ammonia gas will appear as effervescence, all right? And when it involves the formation of precipitate, please note the color of the precipitate and the solubility in excess test reagent. So take note of the complete description. Okay, you can check your notes or check the cheat sheet for more details. And if the precipitate dissolve, please write down the final color. For example, copper 2 plus with aqueous ammonia in excess. The blue precipitate dissolve or soluble in excess aqueous ammonia to form a dark blue solution. That is the complete answer. Whenever a reagent is added to a solid, please record if the solid dissolves and must say the color of the solution, even if it's colorless. For example, the white solid dissolved in acid to form a colorless solution, or the white solid dissolved in water to form a colorless solution. Please do not forget to talk about this solid dissolved and the color of the solution. Please remember that observation is not the same as conclusion. Many students make the mistake of thinking that it is the same. Observation is what you see, conclusion is what you deduce. For example, colorless pungent gas turn moist red litmus paper blue. The word ammonia, the description of ammonia gas form should not be written under observation. It will be marked wrong. You should write under conclusion if there's any. Deduction, do not write copper or copper 2 plus. You have to be specific. Is copper 2 plus present or absent? Do not just say copper 2 plus. Must say copper 2 plus ions are present or are absent. Do not leave the deduction blank if a negative result is obtained. Addition of acid followed by barium nitrate, no precipitate form, you may conclude sulfate ions present. So you must write down no PPT form or no visible reaction. Okay, so you can write this or no visible reaction. If the test doesn't generate any observable result, you cannot say no reaction. That's wrong also. If the gas is evolved, do not simply report the identity of the gas as a deduction. You should deduce the ions. For example, CO2 evolved, so CO3 minus present. At the end of the day, you're not just finding out what are the gases. No, you're finding out the ions in the solution. Please be clear about that. And these are the purpose of the test to be performed. Okay, I just run through very briefly. And okay, the last part, right, consists of 30 pages, which I will not go into the detail. But basically, right, this I just go through one example, just one example. What should you be thinking when you are doing the question? These are past year O-level questions. So for example, you are given two sort solution J and K, carry out the test on J and K and record all your observations. Conclusion must not be written. Now, if you look at J, please note the color. Does it look colored or colorless? If it's colored, what's the color? If it's colorless, mention the solution is colorless. If the solution has a color, what's the color? For example, solution is blue. If they ask you to add aqueous sodium hydroxide, you should immediately think of cations test. If they ask you to let it stand for 5 minutes, think of whether are they verifying if the precipitate, the ions, the metal ions is oxidized by the oxygen in the air. It could be that. Okay, it's a very popular reaction mentioned in QA. If they ask you to add a solution followed by testing the gas, then you must write down the observation for the gas. Okay, test the gas given off means there's a gas given off. If they say test the gas given off, if any, then it may be a situation when there's no gas involved. Okay. Aqueous ammonia, think of test for cation. Dilute nitric acid, silver nitrate. Dilute nitrate, one observation for carbonate, one observation for chloride iodide, any PPT, white PPT or grado PPT, okay, or no PPT. Okay, same thing here. Then for K, it's a repeat. So you look at what they give you and you deduce what could be present. Same for the last one. This is a test for nitrate. How do I know? Aluminum powder. It is similar to aluminum foil because it's just a difference in surface area. But the surface area will not affect the yield or identity of the product form. So it's still ammonia form, which confirm the unknown sample have a nitrate ion. So there are more examples here. I will not go through every one, but it is good for you to read through. Okay, so these are more examples like when they give you reagent test, you're supposed to think of like possible identity. And do not just do it blindly. Understand what you're doing actually, so that you can get the accurate result. Yep. So even like this one is more challenging. Yeah, you are supposed to, they even give things like hydrogen peroxide decomposition, where oxygen gas is involved, and you may even need to test for oxygen gas, blah, blah, blah. Okay, then more examples here, And lastly, right, just a repeat of more example, drilling. So how can you do QA practice without going into the lab? So these are some of the practice about a few practice questions from past year paper. So the teacher, right, can design the question by working backward, meaning either you gave the identity of the unknown right at the start, then ask students, right, to write down the observations and conclusion. Or you give the observation and conclusion based on the color, deduce what could be present like this. So they will carry out, so maybe like this one, based on the conclusion, work backward to write down the observation. Based on the observation, write the conclusion, and then answer some question. This is very good practice. Okay. Yeah, so we can practice this to reinforce the concepts in QA, to prepare the candidate better for the practical. So my idea is that it's good that you can, students are given some practices in school and they have completed the actual practical. So what they can do is that they can cover up the answer, and maybe they can try using the reverse engineering method, meaning since they know what's the identity, right? So they cover up the observation table, and based on the reagent, based on what they know about the substance, write down possible answer. It's a good revision. Yeah, trust me, it will work. This will really sharpen the QA skills. So try to do this. My suggestion is cover up the observations but you work backward. You have the identity of the final product based on the practical you have done, right? Then you work backward to write down oxygen. See if you can get all it correct this time around. Yep. So that's about it. So I hope this is helpful. So thank you.